Hello G, hello G, hello G. Once again, I welcome you all to yet another one-shot session for grade 10. And today, what we are going to learn? Today, we are going to learn about probability. This is a topic which is very interesting and very amazing and very confusing also. But no worries, I'll make sure if you study this chapter from me, or you solve all the questions which I'm going to make you practice, definitely this chapter will be very amazing and easy and a piece of cake for you all. Okay, so without any further ado, let's start the session, and please write in the comments that aren't you amazingly awesome, just like awesome, right? Okay then, so let's start. So first, there are a few things which I want to tell you all before we jump in, right? So the first thing which is there is, what is a random experiment? Okay, so random experiment is nothing but whatever. Let's suppose you are tossing a coin, you are rolling a die, right? So the outcome is not controlled by us, right? Can we control the outcome? Can we control that if we toss a coin, every time the head will come? No, until unless we have a fair coin, right? If we have a fair coin, we'll be always getting head or a tail. We cannot get all the time heads, right? So this is a very important thing that you all should know, that a random experiment is an experiment in which the results cannot be controlled. Now, the next thing is sample space. Now, what is the meaning of sample space? The meaning is very simple. The sample space is nothing but all the possible outcomes. For example, if I'm tossing a coin, then what things will be getting as an outcome? Either the heads or the tail, right? Now, if we toss two coins all together, so what things will be getting? We'll be getting head or a head, right, simultaneously, or tail or a tail, or tail or a head, or heads or a tail. Clear? So these are nothing but called as a sample space. Now, let's assume that we are tossing three coins simultaneously. So what we will be getting? Either head, tail, head, tail, head, tail, head, head, tail, tail, head, tail, head, or tail, tail. So this is how the things are, and this is nothing but the sample space. What is the sample space if we toss three coins? This is the sample space that we'll be getting. Now, there are few things what you all have to observe. The first thing is, when we tossed one coin, what were the outcomes? Two, right? 1 and 2. So this is the thing that we have got. Now, when we toss two coins simultaneously, what we got? We got 1, 2, 3, 4. 4 outcomes. That is 2 raised power 2. Now, when we toss three coins, you can see how many outcomes are there. 1, 2, 3, 4, 5, 6, 7, 8. So 8 outcomes. Similarly, if we toss 4 coins simultaneously, we'll be getting 2 raised to the power 4 as the number of outcomes. Clear? Now, if I proceed further, so let's suppose if we are throwing a die, right? So if we throw a die, what are the outcomes that we'll be getting? The outcomes are very simple. We'll be getting either 1, 2, 3, 4, 5, 6. Apart from 6, apart from these 6 numbers, we won't be getting anything else, right? Do you all agree with me? Yes or no? Right? So this is how the things are. Now, if we throw a die, 2 dice together, let's suppose in the first die we got 1. In the second die, we can also get 1, 2, 3, 4, 5, 6, anything, right? So this is something which is very much interesting, and a lot of questions comes from this concepts. What if we throw 2 die together? What will be the outcome? So the outcomes could be 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, and so on. Clear? And so on. This is how the things are. Clear? Now, if I proceed further, now let's look at the outcome. When we rolled a die, how many outcomes we got? 6. Now, when we rolled 2 die, how many outcomes we have got? See here, we have 6, 6, 6, 6, 6, 6. So 6 into 6 is nothing but 36. So that is nothing but 6 raised to the power 2. When we roll 3 die, what we'll be getting? We'll be getting 6 raised to the power 3. And similarly for 4, 5, 6 and so on. Clear? Understood? Got it? Now, I don't know whether you all play any games related to the cards or not. If you play the games related to the cards, you will be very much familiar with the deck of cards. Now here in deck of cards, you have to understand we have spades, we have heart, we have diamond, and we have for example, here's a bifurcation. We have spades, club, diamond, and heart, right? So spades, in all of them, you would have observed that we have ace, king, queen, and jack, right, or joker. Clear? And we don't start from 1. The deck of cards, they never start from 1. They always start from 2. 2, 3, 4, 5, 6, 7, 8, 9, 10. Clear? So the smallest card is this, then 3, 4, 5, 6, 7, 8, 9, 10, then this jack or joker, queen, king, and ace. Clear? Like this the things are. Now here, what is the thing? We have spades, club, diamond, and heart. Now here you can see what are spades. Spades are basically this one, then this is heart, this is club, and this is diamond. Clear? Got it? So this is how the things are, and we have one queen, one king, one king for spade, one queen for spade, one jack, one ace, 2 to 10 normal cards. Now in club also the same thing, diamonds also the same thing, heart also the same thing. Now here what you all have to observe is nothing but all the cards in spade. We have 13 cards, in club 13 cards, diamond 13 cards, heart 13 cards. So two groups are black, 2 groups are red. Clear? So how many red kings are there? 2. How many red queens are there? 2. How many red jacks are there? 2. How many red aces are there? 2. Clear? So like this. Now again, same goes with the black one. Clear? So total of 52 cards are there. Clear? Understood? I hope this is very, very clear. Now let us proceed further. The next thing is about the events. Now let's suppose if we are going to roll a die, that is an event, right? That is an event. Now if we roll a die, obviously something has to come, right? So let's suppose an event is there in which we are going to roll a die. The outcomes are 1, 2, 3, 4, 5, 6. Now out of, let's suppose someone says, we want the prime numbers to come, right? If we roll a die, we want that the prime number should come. Now, if the prime number should come, then what is the probability that the prime numbers would be coming? Very simple. Here is a formula. Probability of an event is equal to number of favorable outcomes upon total number of outcomes. What is the probability of getting any prime number? Very simple. What is the number of favorable outcome? We have 1, 2, 3. 3. What are the total number of outcomes? How many? What is the sample space? Sample space is 6. So the probability is 3 by 6, which is nothing but 1 by 2. Clear? Probability of an even number. Now, the probability of getting an even number is 1, 2, 3, right? 2, then 4, then 6. 2, 4, and 6, right? So these are the even numbers. So what is the probability again? 3 by 6, which is nothing but 1 by 2. Clear? Now, what is the probability that there will be a multiple of 3? What would be there? The multiple of 3. Very simple. What probabilities are there? What all things are there? Here you can see that we have 1 and 2. So 2 upon how many, what is the sample space? 6. So 2 upon 6 is nothing but 1 by 3. Clear? Understood? Got it? Now the next thing which is there is, this is something which you all have to understand, and around this topic only we'll be solving all the questions. So let's suppose if someone says that let's suppose someone says that sun will rise from the west. What is the probability of that? The probability is 0. Why probability is 0? That is something which is impossible. So something which is impossible will be what? 0. So any event which is impossible, that will be 0. For example, one more thing that people will confuse you is when probability becomes negative. When probability becomes negative, so you have to remember here a very important point, that probability can never be negative. Okay, if an event is impossible, that means it would be 0. Clear? Now, let's suppose there is something, for example, that that is something which is definitely going to happen. For example, let's suppose if you go to the examination, right? If you go to the examination and you have bought 3 new pens, got it? You have bought 3 new pens and you have checked that it is working. Now, what is the probability that during the examination all 3 of them are not working? That is a certain thing that it will work, right? So the probability of it working is 1, right? The probability, let's suppose if someone asks what is the probability that it will be working, all the 3 pens, definitely 1 will be working now. So what will be the thing? The probability is certain, right? Understood? So for example, if someone asks what is the probability that sun will rise from the east, it is definitely going to rise from the east, so it will be 1. Clear? Now if E contains only one outcome, then E is an elementary event. Okay, only one outcome, it is called as elementary event. Now next thing, for any event, just remember that the probability ranges from 0 to 1. It can be 0, it can be 1, and it has to be between that only. Clear? Got it? Now the sum of probability of elementary event in an experiment is always 1. For example, the probability of getting, the probability here, let's suppose the probability of, once again, the probability of getting a prime number is 1 by 2, right? So this is the probability of getting prime number. Now the probability of not getting a prime number is what we have? We have 1, we have 4, we have 6, right? So again 3. So remember that probability of getting E1 is 1 by 2. The probability of not getting E1 is also 1 by 2, that is 3 by 6. So remember, if we add, what is the thing? We are getting as 1, right? So whenever the sum of probability in an elementary event, it will always be 1. Okay. So the next point is related to the same thing, that is probability of A and probability of B. The sum will be always 1, and A and B are complementary event. Complementary event in the sense, if A is 1 by 2, B will be also 1 by 2. Let's suppose if A is 3 by 4, then B will be 1 by 4. Clear? Easy? Their sum should be 1. Got it? Now next thing, let's solve some questions directly and you will understand the concept in a more detailed way. So let's suppose this is a question. Okay, this is an important question. An unbiased die is thrown, what is the probability of getting? So first of all, let's understand what is unbiased die. So unbiased die, if we have unbiased die, what is the meaning of unbiased? Unbiased means it is a fair die. That is, we have all the sample spaces, 1, 2, 3, 4, 5, 6. Got it? We are not being fair, we are not being unfair, right? For example, some people, what they do is they make the side of 6 as heavy, so that whenever we are just rolling die, 6 will come. No, this is not the die. We are talking about unbiased die, that is a fair die. Clear? So what is the probability of getting an even number? Very simple. What are the even numbers? First of all, what is the sample space? The sample space is 1, 2, 3, 4, 5, 6. This is the sample space. Now, what are the even numbers here? 2, 4, 6. So the probability of getting an even number is nothing but how many outcomes? 3. So 3 and total is 6. So it is nothing but 1 by 2. Clear? Multiple of 3. Now multiple of 3 are what? 3 and 6, right? So the probability would be nothing but 2 by 6, which is 1 by 3. An even number or a multiple of 3. Now here, understood, here we have or, that means we have to take that point also. So both we have to include. It's not like we have to exclude one. No, Both we have to include, even number also and multiple also. So what is the probability of an even number? We have got the sample like the favorable outcome as 2, 4 and 6. Now in this 3 and 6 are the multiple of 3. So here 3 will also be included. So now the sample space here would be like the favorable outcome would be 2, 3, 4 and 6, which is nothing but 4 by 6, which will be 2 by 3. Clear? Easy, simple. Now an even number and multiple of 3. They are asking an even number and. So and means we have to take the intersection, that is which is common in both. Even number. So we have 2, 4 and 6 and multiple of 3, that is only 6. So the probability would be nothing but 1 by 6. Clear? Got it? Because we have 6, right? That is only one favorable outcome. So 1 upon 6 is the answer. The numbers between 3 and 6. So number between 3 and 6 is nothing but 4 and 5. So the probability will be 2 by 6, which is 1 by 3. Clear? Understood? Easy. So this is very simple question, and this question can come for 3 marks. Okay, 3 or 2.5 marks. That depends. Okay. Now let us proceed further. So the next thing is, okay, so this question was asked in 2010 and 2013. 2 unbiased coins are tossed simultaneously. Find the probability of getting 2 heads. First of all, let's write the sample space. So the sample space is tail head, right? Head tail, head head, or tail tail. These are the outcomes that we are going to get. So the first one they are asking is 2 heads. What is the probability? First of all, what is the total number of outcome? Total number of outcome is nothing but 4, right? Total number of outcomes are nothing but 4. Clear? Now they want 2 heads, right? So 2 heads. What is the thing? We need 2 heads. So 2 heads is possible only in one case, that is this. So favorable outcome is only 1. So 1 by 4 is the answer. 1 head. Now 1 head is coming here and here, right? Exactly 1 head, this. So it is nothing but 2 by 4, which is 1 by 2. At least 1 head. At least 1 head means what? Minimum 1 head. It can be 2 also, right? So minimum 1 head here, where this. So it will be nothing but 3 by 4. At most 1 head. What's the meaning of at most 1 head? No, at most 1 head is nothing but maximum 1 head we require. So maximum 1 head is where? 1 and 2. So it will be 2 by 4, which is 1 by 2. No head is only in this one. So it will be 1 by 4. Easy, simple. Anyone having any doubt? I guess this is very, very easy, and I would assume that you all have understood this concept. Okay, you all can write in the chat box if this is completely clear. Okay, should I proceed further? Easy, right? Okay then, let's proceed further. Now, this is a question. The question says 3 unbiased coins are tossed together. Find the probability of getting all heads, 2 heads, 1 head, at least 2 heads. Okay. Now, let's understand. Let's go to the place where we have tossed 3 coins, right? So these are the outcomes. So what are the outcomes that you will be getting? Head, 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 tail, head, tail, head, tail, head, 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 tail, 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 head, tail, 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 head, and tail, tail, tail. Okay, so these are the possible outcomes that you can get. Now, so using this, let's solve this question. So here we have. Now we have, let's draw down the sample space. Head, 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 tail, then head, tail, head. Next would be tail, tail, tail. Next would be tail, tail, head. Next would be tail, head, tail. Okay. Now 2 more cases, which would be head, tail, tail, and Next would be head. Okay, we have written head, tail, tail, and what is left? One more is left, which is tail, head, head, right? Tail, head, head is left. Clear? Tail, head, head. Now let's understand this thing. All heads, which is possible only once. How many outcomes we can get? 1, 2, 3, 4, 5, 6, 7, 8, right? So total we can get is 8 outcomes. So all heads only possible once, so 1 by 8. Two heads where all we can get. Now here there are two things. First of all, they are asking two heads. Now here they didn't specify they want only two heads or they can get more than two heads. So in this question also, if you see, we want one head. So one head here also, they both can have the same answer also, right? This can have 3 by 4 also, because one head is there in all the cases, right? Apart from this one. Clear? Now, if they're asking about two heads, exactly two heads, so what we can do is, once again, so here we have 1, 2, then 3, then, okay, so it will be nothing but 3 by 8, right? What they want the cases in which two heads would be the 1, 2, and 3, right? Now, one head, exactly one head is where? Is here 1, 2, and 3. Right? This is exactly one head, so it will be 3 by 8. Now, at least two heads. At least two head means minimum two heads. It can have more than that. So 1, 2, 3. So it will be 3 by 8. Now here the answer could be 2 by 4 also, 2 by 8 also, which is 1 by 4. Right? Clear? Understood? Got it? If exactly two heads they are asking, then it will be 1 by 4. If they are asking at least two heads, so it will be 3 by 8. Clear? Okay then. Now, next. Now, this is very interesting question. The question says, a game consists of tossing a 1 rupee coin 3 times and noting its outcome each time. Hanif wins all tosses give the same result. Sorry, Hanif wins if all the tosses give the same result. 3 heads or 3 tails, and loses otherwise. Fine. What happens? He wins if he gets 3 heads or 3 tails. Clear? Now they're asking, calculate the probability that Hanif will lose the game. Okay. So we know there are total 8 outcomes. So 3 heads and 3 tails. Only one outcome, right? 1 plus 1. So the favorable outcome is 2 by 8, right? When he will win. So which is nothing but 1 by 4. Now, what is the probability that he'll be calculate the probability of losing the game? We know winning plus losing will be 1. So probability of winning the game is 1 by 4. Losing would be what? Let's find it out. It will be nothing but 1 minus 1 by 4. So if we find out, we will get 4, and this will be 4 minus 1, which is 3 by 4. So the probability of losing the game is 3 by 4. Clear? Understood? I hope this is completely understandable. Now, and moreover, this question was asked twice. Okay, so you have to be cautious. This question can also come. Now, next is this question. Now, this is very, very much important question, which always comes here and there. Not exactly this, but sometimes they use this concept to ask different questions. So the question says there is a game of tossing 3 coins. The entry fee in the game is 200. Shikha takes entry in the game by paying the entry fee. The rules of the game are, if tossing 3 coins or 1 coin 3 times, she gets 1 or 2 heads, the entry fee is refunded. Okay. Now they are asking the entry fee is refunded. If she gets 3 heads, she receives double the amount paid as entry fee. Otherwise, she loses the entry fee. Okay. So very simple. She has paid how much? 200. If she gets what? if she gets refunded when? If she gets 3 head, right? If she gets 3 head, the amount, tossing 3, if she gets 1 or 2 head, okay, if she gets 1 or 2 heads, then what happens? There is a refund, right? What is there? There is a refund. Clear? Understood? Now the next thing which is there is, which is very, very much important, that if she gets 3 heads, what is the thing? The amount, whatever she has got, that will be doubled. The amount that she has paid will be doubled. That means she'll be getting 400. Now otherwise what happens? She will be losing the entry fee. So let's solve the questions. So the first thing, what are the total possible outcomes? Very simple. The total possible outcomes you have seen, that is 8. Probability that Shikha loses the entry fee. Now when she'll be losing the entry fee? When she will be losing the entry fee? She'll be losing the entry fee if at all we have let's see. So let's come back here. So when she will lose the money? If she has apart from these all things. So let's come here. So if she gets 2 head or 1 head, she'll be getting the money, right? She'll be getting the refund. If she gets straight away triple heads, she'll be getting back all the money, right? She'll be getting back, twice of the money. So when she'll be losing the money? So here how many things are there? Head, head, head. So here this. So there is only one chance, 1 out of 8 chance that she'll be losing the money. So the probability is very simple. It would be nothing but what? It will be 1 by 8, right? So option A is correct. Now what are the chances that she'll be getting 400? So 400 in the sense she has to get triple H, right? Head, head, head. What is the probability of that? 1 by 8. Now multiply by 100. That is something which will be the answer. This will be, if we divide by 4, 25. So 25 by 2 is 12.5. So 12.5 is the answer. Now the next is the probability that she gets back her entry fee. What is the probability that she gets back her entry fee? So that is nothing but if she gets 1 or 2 heads. So what is the probability? If you all look here, so 1 or 2. So 1, 2, 3, 4, 5, 6. That is 6 upon 8, which is nothing but, once again, 6 upon 8, which is nothing but 3 by 4. So option B is correct, right? Now the chances of her losing the entry fee is nothing but 1 by 8 was there. So 1 by 8 into 100, which is nothing but 12.5. So option A is correct. Easy, simple. Okay. Now the next thing which is there is this question. So in this question, what is being asked? 5 cards are there. Okay, just remember, we have only 5 cards. And in that, 10 Jack, King and Queen. We have 10 Jack, Queen and King. And also Ace of Diamonds. So they are shuffled downwards. One card is picked at random. What is the probability that the card is Queen? If the King is drawn first and put aside, what is the probability that second card picked is Ace and a King? Okay, or a King. Now, let's understand this thing. Okay, first read the question once again. This is very, very simple. Very, very simple in sense, very, very simple. Okay. So, here, first of all, what is the sample space for us? Sample space is 5 cards. First of all, 10 is there, Jack, Queen, King and Ace. Clear? Now, what is the probability that a card drawn is Queen? What is the probability? We have only one Queen. So, the probability will be 1 by 5. Now, what has happened is, there were these many 5 cards. So, we took what? we got 1, we got king, and we did what? We removed the king from there, right? We removed the king from the sample space. So if we remove the sample space from here, what will be there if we remove the king? If we remove the king, we will be having only 4 cards. We'll be having what? 4 cards. Now, if we have 4 cards, out of which, now we have to find out what is the probability that ace will be picked. Ace will be what? 1, right? And out of how many? 4. So we have 1 by 4. Now, what is the probability of king? What the probability of king is nothing but 1 upon, again, 4. Sorry, probability of the king. Probability of the king will be 0. Why 0? Because we have removed the king, right? We drew the king from the sample space, right? We removed it and placed it somewhere. So the probability would be nothing but 0. This is very, very much important. Clear? Understood? Now, they can, instead of king, they can remove queen, and then they will ask, what is the probability of getting a queen? Again, it will be 0. Clear? Okay. Now, so this question was asked multiple times, and every 5 years they have asked, for 2008, 13, 18, okay, 20 maybe, this time they can ask. So what is happening is 2 die they have thrown simultaneously. Find the probability of getting an even number as a sum. Okay, even number as a sum. The sum as prime number, a total of at least 10 doublet of a even number, a sum multiple of 2 on each die and the multiple of 3 on the other, fine, and the sum of both dice, that is doublet, okay, and the multiple of 3 as a sum. Now this question is very simple, I'll just explain you. So this is the sample space, right? So the first one, even number as a sum. So whenever we have 2 odd number or 2 even numbers, then that time the sum would be even, right? See, whenever we have 2 even numbers or 2 odd numbers, that time the sum would be even. So here you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, like this, right? So this question I'm not going to solve. Here what you have to do is you write down all the sample spaces and then you have to check. Now this question will definitely come for a huge number of marks. Maybe they used to ask for 8 marks, okay? Or they can ask for 5 marks, 6 marks also. It depends, clear? So this is how the things are. And if I proceed further, the next question is very simple. Now this is a completely analytical question. Now what do you mean by analytical question? So Peter throws 2 different dice together and finds the product of 2 numbers obtained. Okay, so he has thrown the die and he will be getting the numbers, right? Now whatever the numbers are appearing, he is just multiplying it. Reena throws a die and squares the number obtained. Who has a better chance to get a number as 25? Okay, now this is very interesting. Okay, this is very interesting. Now why this is very interesting? Let's understand. So Peter is throwing what? The numbers, the die, right? So now here you all can see that what is the probability that the product of 2 numbers will be 25. Now it is only possible when we have 5, 5. The total sample space is how many? 36. So what is the probability that he'll be getting the product as 25? That is only possible when we have 5 and 5. You can see if this is 30, 24, 20, 15. So not possible. Only in this case it is possible. So the probability of Peter getting 25 is 1 by 36. Now on the other hand, what Reena did? Reena did nothing, but she has only 1 die and she is throwing it, and the probability of getting what we have to get, we have to get the probability as, we have to get the whatever the number we are getting, we have to square it. So the probability will be very simple. It will be like, what is sample space? 1, 2, 3, 4, 5, and 6, right? Now if we remove, if we check, this 1 square is 1, 4, 9, 16, 25, 36, right? So here, when we are squaring 5, we are getting 25. So what is the probability of this getting 5? It is nothing but 1 by 6. Now who has more chance? Now who has more chance to, who has more chance? You all only tell me. Who has more chance of getting, who all have more chance of getting 25? Obviously Reena, right? Obviously it's Reena, not what? Not Peter. So that's why the answer would be 1 by 6. Clear? Sorry, the answer would be Reena. Reena has a better chance of getting the number. Now, let's understand this question. This question was asked last year. The number of red balls in a bag, is 10 more than the number of black balls. If the probability of drawing a red ball at random from this bag is 3 by 5, then the total number of balls in the bag is, okay. So now this question is related to linear equation in one variable. So related to that, we have to solve this question, okay. So you can see that whatever we have studied in 7th, 8th, 9th, even 6th also. So all the concepts are being interrelated, okay. All the concepts are being interrelated. Now, the thing is very simple. What is the thing? The thing is very, very simple. So let's assume that the number of black balls are X, okay. So the number of red balls will be how much? The number of red balls will be nothing but X plus 10, right? The number of red balls will be X plus 10. So now what is the total number of balls? The total number X plus 10, which is 2x plus 10, right? This is the thing. Now, if the probability of drawing a red ball at random, so if we have a red ball, what is that? If I have a red ball, then what would be the thing here? The things are very simple. Let's understand. Probability of getting a red ball is 3 by 5. Now, the number of red balls is X plus 10, right? And the total number of balls are 2x plus 10. Clear? Now, cross multiply, what we'll be getting? We'll be getting 6x plus 30, and here we'll be getting 5x plus 50. Clear? So, if I just subtract, it will be x is equal to 20. So, there are 20 red balls, and the total number of balls would be nothing but 2 into 20 plus 10, which is nothing but 50 balls. Easy, simple, got it? I hope you all have understood this. Very, very simple. So what we need to do is we need to solve the equation. That's it, linear equation in one variable, and that will give us the answer. Easy, simple. Now let's proceed further. Okay, now this question again, it was asked in the last year. So last year this question was, so just read the question. The question says a bag contains ball numbered from 2 to 91 such that the ball bears different numbers. A ball is randomly drawn out of the bag. Find the probability that it bears 2-digit ball, and next one, it bears the multiple of 1. Clear? Now, first of all, you all tell me that how many balls are there. This is very, very much important. How many balls are there? So first of all, let's suppose the ball, the numbers are from 1 to 91. So how many numbers are there? If the balls are from 1 to 91, how many numbers are there? 91. Now if I remove 1 from it and I start from 2, how many would be there? Definitely it would be from, like, how many balls would be there? 90 balls would be there. Clear? Now the first question it asks is, it bears 2 digits. So let's start. 2, 3, 4, 5, 6, 7, 8, 9 and 10. So how many single digits are there? 1, 2, 3, 4, 5, 6, 7, 8. Now, just remove these numbers. So we'll be having all the double digit numbers. So what would be the thing? Remove 98 minus 8. Sorry, 90 minus 8, right? 90 minus 8 is how much? 82. So we have 82 double digit numbers, right? 82 double digit numbers. So what is the probability that we'll be getting a 2-digit number? So it will be 82 by 90. Clear? Understood? Got it? Now you can simplify also. This will be, if I divide 45, it will be 41. So the answer will be 41 by 45. Now it bears the multiple of 1. Now any number you choose from here, all of them are multiple of Multiple of 1. So this is a short event. So the probability will be what? The probability will be 1. Clear? Easy? Simple? Anyone having any doubt in this question? Very, very simple. Okay. Now this is also very important question, and related to this, every here and there they ask the question. Now there are two friends, Anil and Ashraf. They were born in the month of December. Okay. In 2010, find the probability that they share the same date of birth, and second probability they have different date of birth. Now in December, how many days are there? 31 days are there. Now what is the probability that they will be having exactly same date of birth? Okay, exactly. That is, out of 31, that would be 1 by 31, right? Now if we go theoretically, if we explain, let's suppose Anil is born on 1st, then Ashraf could be born on 1, then 1, 2, right? 1, 3, 1, 4, and so on till 131. Now same thing, second like this. So they are at 31. So basically there will be the chances of getting how many, like what is the total number of outcome? 31 into 31, right? 31 into 31, yes or no? See, this is 31, this again 31, this 3 to 31 again, then similarly we'll go from 31 1, 31 2, 32, 33, sorry, 31 3, 31 4, like this. So that will be like 31 again, 31. So basically we'll be having 31 into 31 sample space, right? Clear? Now what are the favorable outcomes? We'll get 1 1, we'll get 2 2, we'll get 3 3, 4 4, 5 5, 6 6, 7 7, 8 8, 9 9, 10 10. So up to where? Up to 31. So the favorable outcome would be 31. So 31 cancel. The answer would be 1 upon 31. This is this probability of getting the same getting the same date of birth. Now what is the probability? What is the probability that they'll be getting the different dates of birth? This is what the favorable is. Subtracted from 1, then we will get what? If I subtract 1 minus 1 upon 31, we'll be getting nothing but 31 minus 1 by 31, which is 30 by 31, and that's the answer. Clear? Easy? Simple? This is very, 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 very simple, and you have to understand that these all questions, sometimes will confuse you, but in reality, this is as simple as doing a normal thing. Clear? Okay. Now let's move on to the next question. Find the probability of getting 53 Sundays in a non-leap year. Not leap year, they're asking non-leap year. Okay. So first of all, how many weeks are there? How many weeks are there in a year? So total days are 365. If I divide 365 by 7, so what we'll be getting? 5, we will be getting 35, here 1, 5. So 2, 40, so 1. So 52 weeks plus 1 day, right? 52 weeks plus 1 day, right? This is how the non-leap year is. Now basically what you all have to understand is this 1 day could be anything. In a week, how many days are there? 7 days are there, right? It could be Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. Now they're asking what is the probability that there will be 53 Sundays. So this is clear that 52 is there. This is sorted. This is in a group, right? This is in the group. Now 1 day is left, right? So if someone asks what is the probability that there will be 52 Sundays in a year, right? So considering that would be like a sure shot event, right? This is going to happen, right? 52 is definitely that something which is going to happen. Now, if they're asking one more, what is the thing? Okay, what is the thing here? So these are the sample space, and what is the probability? What is the probability that we'll be getting a Sunday? It is nothing but 1 out of 7. So for a non-leap year, it would be nothing but 1 upon 7. Now, what if the question asks if it is a leap year? What if the question asks if it is leap year? Now understand this thing. In a leap year, how many days are there? 366. If I divide by 7, again, we'll get 52. But this time we have 2 days in hand. Now, again, same thing. What would be the probability that it will be a Sunday? Now here we had only 1 day. Now here we are having 2 days. So the probability will be 2 by 7. Clear? Easy? Simple? And these type of questions they can ask here and there. Non-leap year and leap year. Okay? So I've seen that multiple times they have asked this question. So you have to be very much mindful with this question. Divide 365 by 7, you'll get 52 weeks and 1 day. 366 divided by 7, you'll get 52 weeks plus 2 days. Right? So the sample space is Monday, Tuesday, Wednesday, Friday, Saturday, Sunday. 7 days. And we have 1 day in leap year, non-leap year, and 2 days in leap year. So divide by, that is the favorable outcome, right? So 1 upon 7 and 2 upon 7 will be the answer respectively. Clear? Okay. Now, this is the question which was asked last year. So a girl calculates the probability of her winning first prize in lottery is 0.08. If 8,000 tickets are sold, how many tickets she would have bought? Fine. So they have given us the probability. What is the probability? Number of, one second. Favorable outcomes upon total number of outcomes. Clear? So probability has given 0.08. What is a total number of favorable outcome? We don't know. That how many tickets she has bought? Don't know. Tickets bought. Now, total number of tickets were sold was 8,000. So if we multiply these two, we'll get the answer. So ticket bought would be nothing but 0.08 into 8,000, right? So if we do this thing, okay, this was 0.6, okay? My bad, this was 0.6. So if we do the multiplication, we'll get 480. So option C would be correct. Clear? Easy. So remember, this is not 0.8, 0.008, this is 0.06. Clear? So this would be the answer, and this is the thing. So today, what are the things we studied? First of all, let's quickly revise all the things. Now understand there are few things that here we have 52 cards. Now if someone asks how many red cards are there, so you'll say that there are a total of 26 red cards. Now what's the probability of getting a red card? Would be nothing but 26 by 52, which is 1 by 2. Clear? Now if someone asks what is the probability of getting a black card, it's same thing, 1 by 2. Now what is the probability of getting a king? Getting a king is very simple. How many kings are there? 1, 2, 3, 4. So 4 upon 52. So that would be nothing but, if we divide, it will be 2 upon, this will be 26, right? So again, we divide, it will be 1 by 13. So the answer will be 1 by 13. Clear? Now same goes with king, same goes with jack, same goes with ace. Now same, will it go same for the number 2? Yes, exactly. We have 4 cards, right? So it will be the same thing. Got it? Now, what will be the probability of getting a red king? What will be the probability of getting a red king? Now, red king, how many kings are there? 2. So 2 upon 52, that would be the thing. So 1 upon 26. Same thing, black king is the same thing. Clear? So according to this, they will be asking few questions, okay? And that's the thing. Now, face cards are, we have 4 face cards. So face cards are ace, queen, we have 4 face cards. So this is the thing, king, queen, jack, ace. These are the face cards, clear? Now, they can ask how many face cards are there. So it will be 4 into, face cards are 12. Basically, king, queen, and jack. So 12 face cards are there, king, queen, and jack. So what is the probability of getting a face card? So it will be 12 by 52. Clear? Now, this thing is very, very much important, that when we are rolling a die, they will always ask about rolling 2 die. Now, whenever we are rolling 2 dice, there will be 36 outcomes. Remember, this is something which they can ask, that what is the probability that we're getting the same numbers in both the die. So how many outcomes? 1, 2, 3, 4, 5, 6. So the favorable outcome is 6 by 36. That is 1 by 6. Okay, got it? Now, these all questions, I've practiced you all, but this is something which they can ask in MCQ, that if 5 coins are tossed, what is the probability of, what is the sample space? So you have to do nothing. You have to just do what? 2 raised to the power 5. Clear? And that's it. So this brings us to the end of the session. So that's it. Now we have a section called as Ask Me Anything. So what you can do is, if you have any doubt, you can install the app and go to the doubt section. There you can ask any doubt. Just upload the photo, and then our teachers will be there to help you. Within 10 to 15 minutes, you'll be getting a call and they'll be resolving it out. Okay, so if you like the session, please do like, share, and subscribe. And that's it. Thank you so much. And please practice. Now we don't have that much amount of time. So just practice. Do not learn new concepts. Just practice. And you remember, practice makes everyone perfect. So that's it. Thank you so much. And bye everyone.